more rational expressions. Again, they're added and subtracted, which means we need common denominators. The new thing here is that these denominators already have something in common, so what you don't want to do is go, this first fraction contains a 5x, so I need a 5x over here. This fraction contains a 10x, so I need a 10x over here. That's inelegant, and it gives you numbers that are much too big compared to what they need to be. So with these, you have to look at what each fraction already contains and then figure out how to add just the little pieces that it genuinely needs. For the numbers, for instance, 5 and 10, don't go to 50. The smallest number that 5 and 10 both go into is simply 10, which means this right side fraction is fine, and the left fraction only needs a 2 to get its numbers squared away. As for x's, this one contains an x, and so does this one, so there's really no need to add anything there. Just double the left fraction, and you get 6 over 10x minus 3 over 10x, and then we can combine those into a single fraction whose common denominator will be 10x and its numerator will be 6, take away 3. So, much simpler than it could have been. For non-permissible values, it's the usual drill. You take the denominator, 10x, and you say, this cannot be 0. Then you divide both sides by 10, and ignore that, please. 10x divided by 10 makes x. Nothing divided by 10 makes nothing, so our non-permissible value is x must not be 0. Now here, these don't have anything obviously in common unless you factor them, and then something neat happens. If you factor the left-hand denominator, you get 5x plus 1. Factor the right-hand denominator, 2 comes out, and you're left with, x plus 1. So these already have quite a lot in common. All that we need to do to make them match is, since this first fraction contains a 5, the right fraction has to be given a 5. And because the right fraction contains a 2, the left one must be given a 2. Now that that's sorted out, we have 2 times 4 is 8 over, what is that, 10x plus 1. And for the right-hand fraction, 3 times 5 is 15. And then we have 10x plus 1. Combine those into one fraction with their shared denominator. And 8 plus 15 makes 23, and there it is simplified. So factor the denominators and then decide how much new stuff you need to add to make the denominators match. For non-permissibles here, well, either 10 cannot equal 0, I'm not worried about that, 10 never equals 0, but we also have x plus 1 can't equal 0, which means x must never equal -1. That's our only NPV. Last one. Again, we're going to factor this before we make any decisions about the denominators. First one's 1 over x squared, minus 1 over, take out an x plus 2. So now, what does each of these need to make them match up? X squared, this one has more x's than anybody else, so there's no need to add more, but the first fraction needs an x plus 2. And we need one downstairs as well. And the second fraction, it contains an x plus 2, that's fine, but it only contains a single x where this one contains x squared, so the denominator needs an additional x. And of course I have to do that upstairs as well. So now when we clean this up, our denominator is going to be x squared x plus 2. And upstairs we get 1 times x, and we get 1 times 2, and then we get minus x. So when you clean that up, x minus x just vanishes. We get 2 over x squared x plus 2. Now, 2 non-permissible values this time. One will come from x squared must not equal 0. Square root both sides of that, and you get x cannot equal 0. And for the second bit, x plus 2 cannot equal 0. Kick the 2 to the right-hand side, and we find that x cannot equal -2. So two non-permissibles for this one.